So today we're going to talk about graphing and solving one-step inequalities with addition and subtraction. So this is section 2.1 and 2.2 in the textbook. So inequalities are very similar to equations. It's just instead of an equal sign, you have what's called an inequality symbol. So like a less than, a greater than, less than or equal to, or greater than or equal to. So take a second and pause the video here and write down these kind of key phrases that are associated with each inequality symbol. So is less than, we know that it could also be is fewer than. For the greater than symbol, it could be is greater than, is more than. For the less than or equal to symbol, it could also be is at most or is no more than. For the greater than or equal to, it could also be is at least or is no less than. So these phrases are really helpful if you have them in your notebook. Just maybe kind of fold the corner down so that if you ever come across a problem that has these different types of phrases, like sometimes is at most or is no more than or at least, those get kind of tricky. So these are really good to have in your notes. So first we're going to review graphing inequalities. So when you graph an inequality, you graph it on a number line. So if I want to graph x is less than 6, my number line is going to have 6 right in the middle of it. So I won't have to worry about like running out of room or anything like that. It's just whatever my x is greater than or less than, I'm going to put that number right in the middle. Okay, and then as the number line goes to the right, the numbers increase. So you'll just increase by 1. So up to 7, up to 8, up to 9. And then as the number line goes to the left, the numbers decrease. So we can go down to 5, down to 4, and down to 3. And then if I'm graphing x is less than 6, that means that x can be any number that's less than 6, but it can't be equal to 6. So because it cannot be equal to 6, we have to graph it with an open dot on 6. And then we have to point our arrow in the direction of every number that is less than 6. So every number that's less than 6, that'll be to the left. So like 5, 4, 3, all those numbers are less than 6. So we can draw our line or our arrow pointing to the left. So anytime you have just a less than symbol or a greater than symbol like up here, when you graph it with an open dot or an open circle over the number. And then for x is greater than or equal to -2, so now my x is based on, or it's relating to the number -2. So I'm going to put -2 right in the middle of my number line. And then as the number line goes to the right, the numbers will increase. So if I increase 1 up from -2, I actually go up to -1. So because I'm dealing with a negative number, I'm just going to get closer to 0. So up 1 from -2 is to -1, up 1 from -1 is to 0, and then up 1 from 0 is 1. And then if I want to go down 1 from -2 is -3, down 1 from -3 is -4, and then down 1 again would bring me to -5. So since x is greater than or equal to -2, because the x can be equal to -2, we put a closed dot over -2. So anytime you have a greater than or equal to or less than or equal to symbol, you graph it with a closed dot over the number. And then I want my arrow to go over all of the values that are greater than or equal to -2. So like -1 is greater than -2, 0, and 1. So my arrow has to point to the right. The one thing to keep in mind when you're graphing inequalities, if the variable is on the left side of the inequality symbol, then the arrow or like the way the inequality symbol points, like this points to the left here, it should match the arrow on your graph. In this inequality symbol, the point goes to the right, and so does our graph. So that is only true if the x is or the variable is on the left-hand side, but that's a really good way to kind of check your work. So for example 1, it's going to be solving an inequality using addition. So we're going to solve and graph this inequality. So anytime you're asked to solve and graph, make sure you do both. So a is x minus 6 is greater than or equal to -10. So if I want to solve this, that means I want to get x by itself. So I need to get rid of that -6. So to undo subtracting 6, I'm going to have to add 6 to both sides. So the minus 6 and the plus 6 cancel out. I can bring down my x, and then I'm going to bring down my greater than or equal to symbol. Make sure you keep it facing the same direction and it's the same exact symbol. So it should be greater than or equal to when you bring it down also. And then negative 10 plus 6. So I have a negative and a positive. So when I have a negative number and a positive number, if I want to figure out what they are together, I can take the difference between the two numbers. So the difference between 10 and 6 is 4. And then you take the sign from the number with the larger absolute value. So the 10 in this case. So since the 10 is negative, my 4 will be negative. So x is greater than or equal to negative 4. So that means negative 4 will go in the middle of my graph. And then if I want to go up from negative 4, so if I want to go to the right, up 1 from negative 4 is negative 3. And then up 1 from negative 3 is negative 2. And then up 1 more would be negative 1. And then for if I want to go down or to the left on my graph, down 1 from negative 4 is negative 5. Down 1 again is negative 6. And then down 1 again would be negative 7. So I have x is greater than or equal to negative 4, so since it's greater than or equal to, it has to be a closed dot. And then I need to highlight or go over all of the x values that are greater than negative 4, greater than or equal to. So greater than would be on the right side. So negative 3 is greater than, negative 2 is greater than, so my arrow is going to point to the right. And you'll notice that the point on my arrow points in the same direction as the point on my inequality. And then for example 2, we're going to solve an inequality using subtraction now. So I have y plus 8 is less than 5. I want to get y by itself. Right now 8 is being added to y. So to undo adding 8, I can subtract 8 from that positive 8, that plus 8, and then whatever I do to the left side of the inequality, I still need to do to the right side. So the 8 minus 8 cancels out. I can bring down my y. I have to bring down my less than symbol. And then 5 minus 8. So I have another problem where there is like a positive number and a negative number. So you can take the difference between the two. So the difference between 5 and 8 is 3. And then you take the sign from the number with the larger absolute value. So in this case, it's 8. So since the 8 is negative, so will the 3. So y is less than negative 3. So negative 3 will go in the middle of my number line. And then if I want to go up from negative 3, up 1 would be negative 2. Up 1 again would be negative 1, up 1 again to 0, and then down 1 would be negative 4, down 1 again, negative 5, down 1 again to negative 6. So y is less than negative 3, so since it's just less than, it can't be equal to, so I need an open circle, and I need to cover all the numbers that are less than or smaller than negative 3. So that means my arrow has to go to the left, because negative 4 is smaller, negative 5 is smaller. And when we graph on a number line, the numbers to the left always get smaller and the numbers to the right always get bigger. So I have my open circle on negative 3, and then my arrow is pointing to the left. So for the practice problems, this would be a good time to pause the video and then practice them on your own, and then play the video when you're ready to check your work. So practice number 1, we're going to solve and graph the inequality. So x minus 5 is greater than negative 3. So I need to get x by itself. Right now 5 is being subtracted from the x. So in order to get it by itself, or in order to undo the minus 5, I'm going to add 5. If I add it to the right side or left side, I need to also add it to the left, if I add it to the left side, I need to also add it to the right side. So the minus 5 and plus 5 cancel each other out. I can bring down the x. Negative 3 plus 5, I have another problem where the signs are different. So I have a negative 3 and a positive 5. So I need to take the difference between the two numbers. The difference between 3 and 5 is 2. Oh no, I messed up. Sorry. Remember to bring down your inequality. Don't just change it to an equal sign like I just did. So the difference between, if we're adding negative 3 and 5, the difference between 3 and 5 is 2, and then you take the sign from the number with the larger absolute value. So in this case it's 5, and 5 is positive, so my 2 will be positive. So x is greater than 2. So that means that 2 goes in the middle of your number line. And then if you go up from 2, go up to 3, 4, 5. You go down from 2 to 1, 0, -1. So x is greater than 2, so I just need an open circle since it's just greater than, it's not equal to. So open circle on 2, and then I need to point my arrow over all the numbers that are greater than or larger than 2. So like 3, 4, 5, those are all greater than 2. So my arrow is pointing to the right. And same thing, the arrow on my graph is pointing the same direction as that like point or arrow on the inequality symbol. And then for practice number 2, we're going to solve in graph y plus 8 is less than or equal to 12. So I have an 8 that's being added to y. If I want to get y by itself, I need to subtract that 8. So 8 minus 8 cancels out. I can bring down my y, bring down my inequality symbol, so y is less than or equal to 12 minus 8, which is just 4. So I have y is less than or equal to 4. So 4 goes in the middle of my number line, go up to 5, 6, 7, and then down to 3, 2, 1. So y is less than or equal to, so it can be equal to, so I need to use a closed dot over 4. Y is less than or equal to 4, so I need to point my arrow over all the numbers that are smaller than 4. So for all the numbers are smaller than 4, that's going to be to the left, like 3, 2, 1. So my arrow will point to the left, and same thing, the point on my graph, or the arrow on my graph, points the same direction as my inequality symbol. So that's only true like if the variable's on the left hand side. I can't stress that enough, so don't always use that as like your go-to for graphing, but it is a nice way to check your work.